Introduction. Curves. We all know a sheet of paper is an example of a plane. When you join a number of points in a plane without any break, what you obtain is a curve. Following figures are examples of curves. Curves are of two types, open and closed. Here are some examples of closed curves and open curves. Closed curves. Open curves. Polygons. Polygon is a closed curve made up of 3 or more line segments. Here are some examples of the curves which are polygons. These closed curves are polygons. These closed curves are not polygons. Convex and concave polygons. Convex, a polygon in which all its diagonals lie completely in its interior, is called a convex polygon. Concave, if a part or any of its diagonals lies in the exterior partially or wholly of the polygon, is called a concave polygon. Convex polygon, concave polygon. Regular and irregular polygons. A polygon is said to be regular if all its sides and all its angles are equal. That is, it is equilateral and equiangular both. An equilateral triangle is a regular polygon as all its sides are equal and each angle measures 60 degrees. Regular polygons. Non-regular polygons. Sum of the measures of the exterior angles of a polygon. The sum of the exterior angles of any polygon with any number of sides is 360 degrees. Quadrilaterals. A quadrilateral ABCD has 4 sides, 4 angles and 4 vertices. The points A, B, C and D are called the vertices of the quadrilateral ABCD. The 4 line segments AB, BC, CD and DA are called the sides of the quadrilateral ABCD. Angle DAB, angle ABC, angle BCD and angle CDA are called the angles of the quadrilateral and are usually denoted as angle A, angle B, angle C and angle D respectively. Remember, a quadrilateral has 10 elements, that is, 4 sides, 4 angles and 2 diagonals. A diagonal divides the quadrilateral in 2 triangles. Convex and concave quadrilateral. Convex. A quadrilateral in which a line containing 2 of its vertices has the remaining 2 vertices on the same side is called a convex quadrilateral. Concave quadrilateral. Consider the quadrilateral ABCD. Line L contains the vertices A and D and the remaining 2 vertices B and C lie on the opposite side of L. Such a quadrilateral is called a concave quadrilateral. Angle sum property of a quadrilateral. The sum of the angles of quadrilateral is 360 degrees or 4 right angles. Example 1. 3 angles of a quadrilateral are 34 degree, 70 degree and 126 degree. Find the measure of the 4th angle. Solution. Let us suppose that the measure of the 4th angle of the quadrilateral be x degree. As we know that the sum of the angles of a quadrilateral is 360 degree. Therefore, 34 degree plus 70 degree plus 126 degree plus x degree is equal to 360 degree. This implies 230 degree plus x degree is equal to 360 degree, or x is equal to 360 degree minus 230 degree, which is equal to 130 degree. Hence, the measure of the fourth angle is 130 degree. Example 2. The angles of a quadrilateral are in the ratio 1:2:2:4. Find the measure of each angle. Solution. Let the ratio constant be x. Thus, the measure of the given angles will be 1x degree, 2x degree, 2x degree, and 4x degree. As we know that the sum of the angles of a quadrilateral is 360 degree, therefore, 1x degree plus 2x degree plus 2x degree plus 4x degree is equal to 360 degree, or 9x degree is equal to 360 degree, or x is equal to 360 degree upon 9, or x is equal to 40 degree. Therefore, the angles are 1x is equal to 1 into 40 degree, 2x is equal to 2 into 40 degree, 2x is equal to 2 into 40 degree, and 4x is equal to 4 into 40 degree. Hence, the angles are 40 degree, 80 degree, 80 degree, and 160 degree. Example 3. The measures of two angles of a quadrilateral are 105 degree and 45 degree, and the other two angles are equal. Find the measure of each of the equal angles. Solution. Let the measure of each of the equal angles be x degree. As we know that the sum of the angles of a quadrilateral is equal to 360 degree, therefore, x degree plus 105 degree plus 45 degree is equal to 360 degree, or 2x degree plus 150 degree is equal to 360 degree, or 2x degree is equal to 360 degree minus 150 degree, or 2x degree is equal to 210 degree, or x degree is equal to 105 degree. Thus, measure of each of the equal angles is 105 degree. Types of quadrilaterals. Convex quadrilaterals are of 6 types. Here is a quadrilateral tree chart showing all its types. Convex quadrilaterals. Special types: trapezium, kite. Trapezium, one pair of opposite sides is parallel. Special type: isosceles trapezium, parallelogram. Pair of non-parallel sides is equal. This shows that every parallelogram is a trapezium. Both pairs of opposite sides are equal. Special types: rectangle, rhombus. Rectangle, all angles are equal to 90 degree. Rhombus, all sides equal. Special type: square. All sides are equal and all angles are of 90 degree. This shows that every square is a rectangle as well as a rhombus. Kite. Both pairs of adjacent sides are equal. Kite. A quadrilateral in which both pairs of adjacent sides are equal. In figure 1, quadrilateral ABCD is a kite. Properties of a parallelogram. Opposite sides of a parallelogram are equal. In a parallelogram, A, Pairs of opposite sides are equal and parallel. B. Pairs of opposite angles are equal. C. Adjacent angles are supplementary. D. Diagonals bisect each other. Properties of a rectangle. A. Measure AB and CD. You observe that AB is equal to CD. Measure BC and AD. You observe that AD is equal to BC. Opposite sides are equal. B. Angle A is equal to angle C is equal to 90 degree and angle B is equal to angle D is equal to 90 degree. Opposite angles are equal. C. Also, angle A plus angle B is equal to 90 degree plus 90 degree is equal to 180 degree is equal to angle B plus angle C is equal to angle C plus angle D, and it is equal to angle D plus angle A. Adjacent angles are supplementary. D. Diagonals bisect each other. Diagonals of a rectangle are equal. Properties of a rhombus. Opposite angles are equal. Adjacent angles are supplementary. Diagonals of a rhombus bisect each other. Diagonals of a rhombus intersect at right angles or are perpendicular to each other. All sides of a rhombus are equal. Opposite angles of a rhombus are equal. Diagonals bisect each other at right angle. Also, diagonals of a rhombus bisect the angles through which they pass. Properties of a square. Alternate interior angles are equal. All its sides are equal. All angles are 90 degree. Diagonals intersect at right angles. The diagonals of a square bisect the angles through which they pass. It is a special type of a parallelogram, so has all the properties of a parallelogram, that is, AB is equal to CD, BC is equal to AD. Opposite sides are equal. Angle A is equal to angle C is equal to 90 degree and angle B is equal to angle D is equal to 90 degree. Opposite angles are equal. Diagonals bisect each other. Diagonals are equal, hence it is a rectangle. Diagonals intersect at right angles. Diagonals of a square bisect the angles through which they pass. Hence we conclude that every square is a rectangle, but every rectangle is not a square. Every square is a rhombus, but every rhombus is not a square.